Good morning, students. In the last class in my channel, I have discussed with you about the different conformers of ethane, the staggered form, the eclipse form, their stability. So, as I told you in the last class, that in the next session I will be discussing about the conformers of cyclohexane, the stability of different forms of the cyclohexane. To understand the stability and the different form of the cyclohexane, हम लोग अभी जो है डिस्कस करने वाले हैं about the theory which we call as the bare strain theory, which is relevant and which is important to understand clearly the stability of cyclohexane. As you can see in this case, what I have indicated over here is I have indicated a molecule called as cyclopropane. What is the bond angle in case of cyclopropane? It is 60 degree. Is it clear? What is the hybridization of this carbon atom? It is sp3. As per this, I expect the angle to be 109 degree 28 minutes, or in some books it is written as 109 degree 5 minutes. Is that thing clear? So what I want to say is that the cyclopropane, the compound that I am talking of, is having the angle strain. The expected angle is 109.5 degree, but what is the bond angle, the inner angle that is present over here? It is 60 degree. It means there is some deviation from the normal tetrahedral angle in this molecule. So to show that how much it is deviating from the normal tetrahedral angle, what I have indicated that this angle of cyclopropane, which I have indicated, is 60 degree, and this complete angle is 109.5 degree. So what we are getting from here is this angle. This is called as the angle of deviation, which is equal to 22.44 degree. I think it is clear. 109.5 degree minus 60 degree कर देंगे. So it will be the sum of this and this angle, and definitely जो angle of deviation होगा, it will be half of this. I have written the formula, a very simple formula to indicate the angle of deviation in the molecule, which is 109.5 degree minus alpha. What is alpha? Alpha is the inner bond angle in case of cyclopropane. So I have got this D. जितना ये D का मैग्नीट्यूड ज्यादा होगा, उतना ही हम क्या कहेंगे, मॉलिक्यूल में एंगल स्ट्रेन प्रेजेंट है. सो आई कैन से वन थिंग कि जो एंगल स्ट्रेन है, it is proportional to D, that is the angle of deviation, and it is inversely related to inner angle. जैसे जैसे inner angle बढ़ता चला जाएगा, it will keep on approaching 109.5 degree. So what I am going to say, the deviation angle will keep on decreasing, and if it decreases, it will reduce the angular strain in the molecule, and more the strain that is present in the molecule, it will reduce the stability of the molecule. So I can say one thing कि stability जो है किसी भी molecule की, it is inversely related to this D, that is called as the angle of deviation, and is proportional to inner angle. जितना ज़्यादा inner angle होगा, is that thing clear? उसको हम किससे relate कर सकते हैं? We can relate it to the stability of the molecule. I think clear है, ठीक है? After this, what we want to say over here is कि अगर मैं cyclopropane का example लेता हूँ, तो यहाँ alpha की value 60 degree है. As we have calculated and indicated over here, the angle of deviation is 22.44 degree. Clear? In case of cyclobutane, the angle, this inner angle is 90 degree and the deviation angle is 9.4 degree. So what happened? The angle of deviation decreases. If angle of deviation decreases, definitely I can say, as far as the angular strain part is concerned, cyclobutane has to be more stable as compared to cyclopropane. In case of cyclopentane, what is the angle? It is 108 degree. The angle of deviation further decreases and it becomes equal to 0.44 degree. And in case of cyclohexane, this angle exceeds 109 degree 28 minutes, and the deviation is minus 5.16 degree. The negative sign is just indicating whether the actual inner angle is greater than 109 degree or it is less than 109 degree. So comparing for all these cycloalkanes, one thing is there, I can see from the numerical value that in case of cyclopentane, जो angle of deviation है, that is minimum, it is coming out to be 0.44 degree, indicating that in this molecule the angle of deviation is minimum and therefore it has to be more stable. But practically it is found that the cyclopentane ring is not most stable ring. It is the six-membered ring that is called as the cyclohexane, which is observed to be most stable ring among the case of cycloalkanes. What the limitation or the drawback of the base chain theory was that he considers that the molecules are planar. उसने हर molecule को flat consider करा. Whereas on a practical aspect, it is observed that the angle can be the bond can be undergo twisting, it can undergo bending, as a result of which there can be the readjustment in the inner angle, and it may happen that the bond angle becomes closer and closer to 109 degree 5 minutes. Is it clear? Or we also say it is 109 degree 28 minutes. That small minute differences are there in differences are there in different books. So that is not the overall issue. So now what we want to understand this thing, that how I am saying that cyclohexane ring is the most stable ring among all the conformers among all the isomers or among all the cycloalkanes. So if we analyze the stability of cycloalkane, we say that the molecule tends to minimize the strain that is present in the molecule. There are three types of strain which I also discussed in the last session also. The first one was the torsional strain, the second one was the steric strain, and the third one was the angular strain, which we are introducing in this part. Because in the open chain compound, as we have discussed in the last class of ethane, propane and butane, so they were not cyclic compound and we were not discussing about the angular strain in those molecules. Is it clear? So हम आगे बढ़ते हैं. Now we have to discuss about the different conformers, different possible forms of cycloalkanes. If we consider the cycloalkanes, we are saying that in this case, after twisting and bending of the molecule, I am observing that there are two forms of cycloalkanes. That is the first form which we are analyzing and we are calling it as the chair form. इसको हम क्या बोलते हैं? Chair form. This is the chair form that I have indicated. In this case, every carbon atom is bonded to two hydrogen atoms. Is it clear? And I can say one thing, that every carbon atom is having two types of bonds. One we call as axial, another we call as equatorial bond. कौन कौन से बॉन्ड होते हैं? एक्सियल होते हैं और ये क्या होते हैं? इक्वेटोरियल बॉन्ड होते हैं. जो एक्सियल बॉन्ड है, दैट इज परपेंडिकुलर टू द प्लेन ऑफ द मॉलिक्यूल, और जो इक्वेटोरियल बॉन्ड है, दैट इज ऑन द प्लेन ऑफ द मॉलिक्यूल. So this is, if I consider this carbon atom, this is axial and this is equatorial. Got the point? If I'm saying, let's say this is the first carbon atom over here. If I say this is the second carbon atom, this carbon-hydrogen bond is said to be the axial bond, as it is present below the plane of the molecule. Any bond that is present perpendicular to the plane of the molecule will be said to be an axial bond. In this case, this will be the equatorial bond, which I am indicating. Here it is axial, और ये क्या हो जाएगा? Equatorial bonds. It is axial. This is equatorial bond. This is axial. This is equatorial bond. Similarly, this is axial and this is equatorial bond. I think you understood this point, that in this case, every carbon hydrogen bond which we are indicating, there are two types of bonds that I have indicated. One we call as the axial, another we call as the equatorial bond. Is it clear? What is this said to be? A shear form of the molecule. इसको हम क्या बोलते हैं? That it is the shear form of the molecule. If we analyze and considering a model of the cyclohexane, everyone can look into this molecule. I have indicated there are two types of atoms over here. One are indicated by green, another are indicated by white. But let us presume that right now they all are hydrogen atoms. Clear? This is a ring, that is cyclohexane ring, which we have indicated. If we consider this molecule, आप देख सकते हैं कि इस molecule में there are 6 atoms which are touching my hands. In addition to this, there are 6 bonds which are indicated above the plane of the molecule. I think it is clear. So what we have to do in this case, what I am saying is that in this case, if I have to form the shear form बनाने के लिए हम क्या करेंगे? I am pushing this bond above the green bond. Clear? और इसके जस्ट सामने वाला जो कार्बन एटम था, उस बॉन्ड को मैंने क्या कर दिया? नीचे कर दिया. So now you can see one thing. What? The molecule has its form as the shear form. इसको हम कौन सी form बोल रहे हैं? It is said to be the shear form. And all the green atoms are present perpendicular to the plane of the molecule. If you consider my hands are touching the green atoms, which are actually which atoms? The hydrogen atom, and they are actually the axial bonds hydrogen atom. The rest, the atom which my hands are not touching, you can see that all these bonds are said to be the equatorial hydrogen atoms. So this is the shear form of the cyclohexane. If I consider the stability, I am observing that in this case, the angle which is present is near to 109 degree. What does that indicate? It indicates that it is free from angular strain. इसमें किसी तरीके का कोई angular strain present नहीं है. Is it clear? The next thing is this: if we analyze the Newman projection of this molecule along the carbon-carbon bond, I am observing that all these atoms and the bonds are present in which form? They are actually present in the staggered form. So if they are present in the staggered form, what does that mean? That it is the most stable conformer of the molecule, as it will be free from the torsional strain. If I tend to draw the Newman projection of the molecule, you can see in this case this hydrogen atom, this hydrogen atom, this, and in this case this will also be the hydrogen atom. If I number the carbon atom, it is 1, 2, 3, 4, 5, 6. This is the shear form of the cyclohexane molecule, and it can be said to be what form? The staggered form. So this cyclohexane shear form that is present is the staggered conformer of cyclohexane, which is the most stable conformer of the cyclohexane molecule. And further, I can say that it is free from the torsional strain, it is free from the angular strain. That increases, that enhances the stability of the molecule. Is that thing clear? So in this case, with the model which I showed you, that it contains the equatorial and the axial bonds that are there. Is it clear? So what happens, अगर हम इस केस में मैंने इस बॉन्ड को ऊपर उठाया था और इसके सामने वाले बॉन्ड को क्या कर दिया था, नीचे कर दिया था. Is that thing clear? Due to which this conformer of cyclohexane was obtained. If I do it in a reverse way, means इस बॉन्ड को मैं ऊपर कर दूं और इस बॉन्ड को क्या कर दें, नीचे. So what we are going to observe in this case, हम यहाँ पे क्या observe करेंगे, that in this case the form that is obtained, is the one where all the white atoms are touching my hands now. You can see this thing. And if they are touching my hands, इसका मतलब ये सारे जो bonds हैं वो कौन से bonds हो गए? They are said to be the जो equatorial bonds थे वो axial हो गए और axial क्या हो गए? Equatorial हो गए. This is called as the flipping in the molecule, जो कि हम next class में और detail में discuss करेंगे. But one thing is sure that as per the bare string theory, we are saying one thing, that it was expected that the 5-member ring, the cyclopentane ring, will be the most stable ring. As we have discussed about the angle of deviation, the inner angle and everything. But बेयर ने क्या कंसिडर करा कि जो मॉलिक्यूल है वो क्या होगा, प्लेनर होगा. That assumption was wrong. In a molecule, the bonds can twist, they can undergo bending, वो modify हो सकते हैं थोड़ा सा, flexible हैं bonds, due to which what happens in that case, we say that it exists in the two form, that is the chair form and the boat form. Further, we have discussed कि जो chair form है, as far as the Newman projection is concerned, it is observed to be what kind of the form? We are saying it is the staggered conformer. The next thing is that again I am considering a different molecule, the same molecule with a different model. That is, this is again cyclohexane. You can see the molecule cyclohexane. Every carbon atom is bonded to two bonds. One is indicated by red, another is indicated by white, although they all are hydrogen atom. To understand certain things, we have made it by two different kind of colors, the atoms. If we consider this, हम यहाँ पर क्या कह रहे हैं कि जो साइक्लोहेक्सेन मॉलिक्यूल है, मैंने चेयर फॉर्म को एनालाइज करने के लिए इसको ऊपर किया था. आई एम डूइंग इट अगेन लाइक दिस, क्लियर. और इसके सामने वाले कार्बन एटम के बॉन्ड को मैंने नीचे शिफ्ट कर दिया था. बट बोथ फॉर्म में मैं क्या कर रहा हूं, आई एम शिफ्टिंग बोथ द बॉन्ड्स अबव. And this is the arrangement that I have obtained. What is this called as? This is called as the boat form of the molecule. इसको हम क्या बोलते हैं? We call it as the boat form of the molecule. If we analyze this CH bond is eclipsing the CH bond that is present behind it. This CH bond is eclipsing this CH bond present behind it. The same thing goes for this CH bond, this CH as well as for this CH. So actual में जो cyclohexane है उसमें हम ये बात कहते हैं कि यहाँ पर जो ये फॉर्म है, as far as the Newman projection is concerned, it is said to be what kind of the form? It is said to be the eclipse form of cyclohexane. The front atoms are eclipsing the atoms which are present behind them. And if we tend to draw the structure in this case, what kind of structure that we are obtaining over here in case of the another form of cyclohexane, this we call as what kind of form? It is said to be the boat form of cyclohexane. इसको हम क्या बोलते हैं? Boat form. This is first, second, third, fourth, fifth, sixth, and you can see one thing that in this case, in this molecule, actual में क्या होता है कि ये जो दो atoms हैं, जो मैंने पकड़ रखे हैं atoms, what happen? These two atoms are very close to each other. So when they are close to each other, these atoms are very close to each other, and this is called as flagpole hydrogens. And these flagpole hydrogens, because of very closeness in their presence, is said to be creating a repulsion, is said to be creating a strain in the molecule, which is called as the flagpole interactions. This two hydrogen atom are creating the flagpole interactions. And definitely in this case also, when I have done the twisting and the bending, the angle is coming out to be 109 degree approximately, which means that it is free from angular strain. The chair form is more stable as compared to the board form, not because of angular strain. The angle is approximately same in both the molecules. The difference lies with respect to the torsional strain. Chair form is more stable because of the minimized torsional strain, as it is considered to be the staggered form. The other form, the board form, which is said to be the what kind of a form? It is indicated as the eclipsed form. If I tend to draw the Newman projection of this board conformer, if you consider this, this is said to be what kind of the form? That is the eclipsed form. This is carbon atom bonded to two hydrogen atom. This is what said to be, it is said to be the eclipse form of the molecule. Is it clear? And in this case, because of the flagpole interactions, as we have said, what happens? The molecule is less stable, the conformer is less stable as compared to the chair form of the molecule. Is it clear? So chair form more stable than the board form because of torsional strain and because of less or minimized flagpole interaction. In case of the eclipse form, the bonds are present in the eclipsed position, and secondly, there is a presence of flagpole interaction that is there, that reduces the stability of the board conformer as compared to the chair form. Although there are other form of cyclohexane also, that is the half chair form and the twist form, वो भी form exist करती हैं, but they are not significant. There is no need to go in detail of that part. We have to mainly focus on these two forms, and in the next session we will be discussing about the substituted cyclohexane, the presence of diaxial interactions, and the geometrical and optical isomerism in the conformers of cyclohexane. Thank you.